Okay, so now that we know how to define variables, we can introduce the power of MATLAB, and that is the use of variables in defining arrays or matrices or vectors or even scalars. I'm using them interchangeably. So the MATLAB strength is not using it as a glorified calculator, rather its strength is in manipulations of matrices and arrays. So I'm going to go in here and clear my screen so we can start in the beginning. So the best way to define an array, let's go ahead and we've already done this, but let's just say I have x equals, I'm going to use the square bracket to define my array. I'm going to say 1, 2, 3, 4, close square bracket, enter. So now I've defined x as an array. I can go ahead and define y as another array. In this case, I'm going to say y equals 1 semicolon 2 semicolon 3 semicolon 4, close, and you'll see the difference between my x is I put spaces in between here, and what that does, it by default defines x as a horizontal array. I can go in here and say, well, no, I want it to be a column or vertical array, and to do that I have to put a semicolon after each number, and it doesn't matter if I put a space or not, but as long as there's a semicolon, it says, okay, 1 semicolon means new line, so I go to the next line, 2 semicolon goes to the next line, and so on and so forth. So now I've defined x as a horizontal array, and if we look at the size here of small x, it's 1 by 4. Look at the size of small y here, it's 4 by 1. So that's how you can tell if it's a horizontal versus a vertical, or a row versus a column. Okay, and we can further define a matrix. We can say, let's say z equals 1, 2, 3, 4 semicolon 2, 3, 4, 5 semicolon 3, 4, 5, 6 close bracket. And what that's going to do is define a matrix. In this case, if you look at z here, it's a 3 by 4 matrix, meaning it has 3 rows and it has 4 columns. So if you pay attention to the notation here, to create a horizontal array, we can just write the numbers with a space, or I can go in here and I can say, for instance, let's just redefine x. X equals 1, 2, 3, 4. That's the same thing as saying x equals 1 space, 2 space, 3 space, 4. So we have the option of using the commas to denote a space, or just put a space to denote there's a space in there, and it's going to be horizontal. So this guy here is equivalent to this guy. So both those will give us the same output. Now we can switch the semicolon, the comma with a semicolon, which is what we did here, and it made it a column. Okay, so then we said, okay, well, if we can define a row and a column, then we can actually define both rows and columns, and that's what we did with variable z. So we said we want to assign these values to the variable z, and we said 1, 2, 3, 4. That's going to be 1 row. Semicolon means new line, so I'm going to go down to a new line, and I'm going to define 2, 3, 4, 5. That's 1 row, semicolon, new line. So we come down here to new line and do 3, 4, 5, 6. So that's a very quick way of defining arrays or matrices in MATLAB, and we'll find that it's very powerful. It's a very powerful method, and we'll see how we can extract data using these matrices or arrays. And this is where MATLAB shines, and it's very powerful in regards to why it's used so much in the industry, engineering industry. Okay, so we'll stop here for now, and then next video we'll talk about the colon operator.